Hey guys, what's up? This is ETSki Tutorials, and this is FPS 1.2. This episode, we're going to be going over how to take the mouse movement and actually turn it into looking around in 3D space, and how that's all going to work. And we got a lot to go over, even though it sounds like a simple concept, so let's get started. So the first thing I like to do when making a new script is list out every variable that I'm going to need. And as you can see for this script, we got a lot of variables. We have 8 variables to be exact, and they are all floats. And they all work together, and they all have their own function. So let's go over each one and see what they all do. Let's start with the look sensitivity. Now look sensitivity is a float, and basically it's what it sounds like. It's the look sensitivity. We need to have this variable so that we can adjust and make the right feeling movement between the mouse and actually looking in 3D space. So what we're going to be doing is basically just multiplying this by the mouse input that we get. If we wanted to, we could do an X sensitivity and a Y sensitivity. A lot of games have that, but let's just keep it simple and use the same sensitivity for both the X and the Y, and it should work all right. The next variable, or the next two variables we have, is Y rotation and X rotation. Basically what these are going to be is target rotations that are going to be saved as Euler angles, or Euler angles, however you pronounce that word. So we're not going to use an actual quaternion for looking around and finding this rotation, because we want to have numbers that are simple, that we can keep track of, and that we can use in between objects. Dimitri, be quiet. I'm trying to make a tutorial. So many distractions. I just got a text. So basically, these are going to be our saved target rotations of where we want the player to turn to based on where the mouse is moving. Next, we have current Y rotation and current X rotation. What these are going to be is the actual amount of degrees that the camera is rotated, whereas this is a target. So we're going to have a smooth damp function to make current Y rotation, current X rotation smoothly catch up with Y rotation and X rotation. So we might lose a little bit of sensitivity and a little bit of accuracy, but it's going to smooth out the camera and things are just going to look so much better. And we'll be able to adjust how quickly it smoothly moves to our target X and Y rotation. So next we have is Y rotation V and X rotation V. And the V stands for velocity. The smooth damp function requires you to have a saved velocity variable. So we don't actually have to mess with this variable too much. We just need to declare the variable and plug it into the function, and smooth damp will do the rest for us. So that's what those two are for. And next we have look smooth damp. So what look smooth damp basically is the amount of time that it's going to take for current Y rotation and current X rotation to catch up with Y rotation and X rotation, so that we get that smooth look when we're moving from side to side or up and down. If we make this number really small, it's going to quickly go to where we need it to go, but it's not going to be as smooth. If we make it a large number, it's going to look very smooth and fluid when we look around, but it's not going to be very accurate, and it's going to be hard to shoot targets very accurately. So we're going to have a predefined variable so that we can adjust that later on and find exactly what we need and get that right balance of fluid movement and accuracy. Alright, so now let's start with the first couple of lines of code that we're going to be putting inside of the update loop. So the first line we have right here is Y rotation plus equals input dot get axis mouse X times look sensitivity. Alright, let's break this down now. We have Y rotation plus equals, so that means we're going to be adding to what Y rotation already is, input dot get axis mouse X. Now what this means is basically we're getting the horizontal movement of the mouse previous to what it was the last frame. So this isn't the X of where it is on the computer screen, it's the X of where it is relative to where it was the last frame. So don't get that confused with where the mouse is on the screen. And then we're multiplying that by look sensitivity because this number here isn't necessarily going to match up with the number of degrees that we want our player to turn or look around. And one thing you might have noticed is I am using the mouse x-axis for Y rotation. Now that might seem confusing at first, but you got to remember that when we rotate around the X, or when we rotate around the Y axis, that's actually giving us a horizontal pan, because um, the the Y axis is vertical; it goes up and down. And when we rotate around that, it's like the y-axis is like an axle, and like the y rotation is like a wheel. So that's why we're using the y rotation for horizontal movement, or horizontal panning, or looking around, or whatever you want to call it. So now let's go over to how we affected the x rotation, which, remember, the x rotation is looking up and down because the x-axis is horizontal. When we rotate around that, we're going, we end up looking up and down. So keep track of that when we go between the y rotation, x rotation. So we have x rotation plus equals input.getAxis mouse y times look sensitivity. So literally it's the exact same thing as this line of code, except for the x-axis, or looking up and down. Alright, now this next line of code should be fairly simple. Basically what this is going to do is just make sure that our character doesn't do front flips and back flips. Because right now when we move the mouse around and say we keep on looking up, our code, or our game, doesn't know yet that we don't want the player to keep on looking up and then keep going backwards and backwards, and eventually just flip all the way around, and you just keep on doing backflips. So basically this is going to clamp the X rotation in between -90 and 90. So the most we can look up is straight up, and the most we can look down is straight down. And we don't have to worry about doing the same thing with the Y rotation, because it doesn't matter if we start spinning in circles with the Y rotation, because you can do that in real life if you want to. If you want to spin around, go ahead and let the player do that. But it's unrealistic to be doing backflips and front flips from just a standing position. So let's go over how this works. We have x rotation equals mathf dot clamp x rotation -90, 90. So what math clamp does is you give it three float variables, and then it'll give you a variable back. So basically what it's going to do is it's going to clamp the first variable that you give it, and we gave it x rotation, which is the same thing as what we're affecting here. And then the second variable you give it is the minimum, and then the third variable is the maximum. So what math clamp is going to do is, if the first variable, or x rotation, is less than -90, it's going to give you back -90, or if it's more than 90, it's going to give you back 90. So basically it's just going to make sure it doesn't go less than this or more than this. So it clamps it between those two. And then we have it saved in x rotation. So it's just making sure that it doesn't go over 90 or less than -90. Alright, our next two lines of code are basically going to be changing current x rotation and current y rotation smoothly into x rotation, y rotation. So it's moving our current exact where we are rotation and smoothly transitioning that into our target where we want to be rotation. So let's go over current x rotation equals mathf dot smooth damp current x rotation, x rotation, x rotation v, look smooth damp. So that sounds confusing, but smooth damp is actually a pretty simple function. Mathf dot smooth damp, we're going to give it our current variable, or the variable that we want to smoothly transition into our second variable, which we have written here, which is x rotation. And then our third variable that we give it is x rotation v, or the velocity variable. So this is just a variable that we need to save the velocity, so that we get this smooth, realistic movement. And when we give it the x rotation v, or our velocity variable, that's all we gotta do. We just gotta give it to smooth damp, and smooth damp does the rest. We don't need to worry about that variable after that. And then we have look smooth damp, and this is basically the approximate amount of time that we want it to take for our current variable to reach the target variable. So let's go over that one more time. We just have current x rotation equals mathf.smoothDamp current x rotation. So we're saving where we are now, and then we're moving towards our target, and this is our current velocity, and this is the approximate amount of time that we want current x rotation to reach, or x rotation. I think that made sense. And then we have the exact same line down here, but all of the x's have been changed to y. We just needed to do the same line twice for both the x and the y, because we want them to both smoothly reach their targets. My hand's stuck. Okay, now that we have our current x and y rotations smoothly moving towards our target x and y rotations based on the mouse movement, let's actually apply that to the transform and physically move this camera around. So we have transform.rotation equals quaternion.Euler current x rotation, current y rotation, 0. So what that means is that we're taking transform.rotation, which is a quaternion, and we're having it equal quaternion.Euler. So quaternion.Euler is a function that's going to return you a quaternion based on an x, y, and z you give it in Euler angles. So we're giving it the x rotation, the y rotation, and 0, because we don't want it to rotate around the z-axis, because that's this sort of movement. And for right now, there's really no purposeful reason why we need that in a first-person shooter. There's like no control to make the player do this, so there's no reason to even affect that. So we're just going to leave it at 0, and we're only going to rotate around the x-axis, which is an up and down movement, and the y-axis, which is going to be our horizontal movement. So that's the last line we're going to go over today. So yeah, hopefully that all made sense, and now we're going to go on the computer and see how to do that in Unity. Alright, here we are inside of Unity, and this is the first-person shooter. This is what we're going to be making. But we want to start from scratch because I want to show you from very beginning to very end how to make this first-person shooter. So let's go up to File, New Project, and Set. And I want to save this on my desktop, and I'm going to call this FPS, no, not FPA, FPS1. Save. And we're going to have all of these checkboxes down here unchecked because we want a totally blank slate and we want to create everything ourselves. So let's not import anything. Let's just do everything ourselves and have a completely blank project. So now I think I can just press Control Save. Alright. So we have a default blank scene open, but we need to save it inside of our assets folder to actually be able to see it in the project window and to refer back to it later. So here we are, we have level 1 open, and there's nothing in here except for our main camera. So let's zoom into that. So there we are, there's our camera, and let's put some things for our camera to see. So game object, create other cube. So let's start with a floor sort of dealio. Make it flatter, make it a bit bigger. Okay, now we have a basic floor. Now I pressed Command D to duplicate that. And I'm just making shapes right now because we're making a mouse look script. We want to have some things for the camera to actually look at so that we can know when we're actually looking around and what we're looking at, and you know, because you can't tell if your script's working if all you're looking at is just plain blue emptiness. And let's throw a point light in there. Game object, create other point light. Ooh, that's pretty. So I think that is pretty interesting enough. We'll be able to look around and make sure the game's working the way it properly should now that we have things to look at. Alright, and I'm going to now create an empty game object, and I'm going to call that level stuff. And I'm going to throw all of those cubes inside of level stuff, and I might as well throw the point light in there too. Alright, now let's create a JavaScript, and we're going to call this mouse look script. And we are going to attach this to the main camera, and let's open that up, and it should be totally blank. There we go. Alright, now first let's start with all those variables that we listed. So if I remember right, the first one is look sensitivity float, and let's give it a default value of, I don't know, 5. I usually just like to ballpark the default values and knowing that I'm going to change them later. So let me just save this and show you what that does. So right now I have var look sensitivity float equals 5. If I were to get rid of this there, it would be default an integer because 5 is an integer. I'd have to write like 0.0 for it to register as a float. But I usually just like to declare my variables exactly as what they're going to be. Oops, I spelled that wrong. Float. There we go. So there we go. Float equals 5. So let me go back to Unity and show you. There we go. So now we can adjust this number at any point in time right inside of the inspector so that we don't need to go into the script to tweak things. So let me go back and let me just show you what happens if I just declare it as a float and I don't give it a value. It should have a default value of 0. Well, I gave it a value of 5, so I'm going to have to remove that component and then put it back on. So see, default value of 0, but I can still change it just the same. But because I just like having default ballpark values, because I'm just going to guess that's going to be around 5. Okay, let's just keep rolling here. We got var y rotation float. We don't need to give that a value right now. Var x rotation float. Var current x rotation. So I'm going to do y first just to keep things organized. Rotation. Okay, what came next? Oh yeah, the velocities. So for y rotation v float x rotation v float. Now our look smooth down float, and I'm going to give this one a default value of 0.1, which, just like look sensitivity, I'm probably going to change later. Now the reason why I didn't give default values to all of these is because basically if I were to give this a default value, it would be the starting X or Y rotation of where the player is going to be in the world, which really isn't that necessary, and that's not something you're going to want to edit in the inspector. Later on, I might add a script so that it sets the default value to where you place the player in the scene when you're using the level editor. But for now, we're just going to have it face the default straightforward in the world, and it's not that big of a deal because you're going to be turning the player around all the time anyways. So yeah, alright, we got all of our variables in place, and now let's start going with our code. Crap, what was that first line of code? Oh yeah, it was y rotation rotation plus equals input dot get axis mouse x times look sensitivity. Alright, and you know what? I'm going to be lazy and I'm going to copy and paste this. Voila, less work for me. Alright, next I'm going to do these codes a little bit out of line just because I want to test it as we go. So I'm going to do now transform dot rotation equals quaternion dot Euler, and we want x rotation y rotation comma 0. So this is different from what I was talking about a second ago, but I just wanted to be able to test this out very quickly and test as we go along to make sure this is working and to see if anything needs to be changed. So right now, basically what this is going to do is the same thing as all the code that I just explained on the camera, except we don't have the smooth damp function in place yet, and we also don't have a limit on looking up and down. So you can do backflips right now and things aren't going to be very smooth. So let's go ahead and run that and take a look and see how well that works. Okay, that's looking pretty good, except for the fact that it's inverted, which I don't really like, and maybe later we can add an option if some players prefer it to be inverted, but I'm just going to change that to minus equals just to reverse the up and down looking movement. So there we go, that feels a lot more natural and a lot more like average first-person shooters, but the movement is very, very jumpy and there's a lot of screen tearing and it's just overall not smooth. It's accurate, I guess, if you want really good accuracy going on, but I would rather have it smoothed out. So let's put that smooth damp function in place. So we're going to do current x rotation equals mathf dot smooth damp. Whoops, not smooth damp angle, just plain smooth damp. And first we want current x rotation, and then we want x rotation, and then we want x rotation v, and then we want look smooth damp. Alright, so that was pretty quick and painless. Now let's go ahead and completely copy that and just change all of the x's to y's. Make sure whenever you copy and paste lines like this, where you change all the x's to y's, or just copying stuff like that, just make sure you get every x or every y, because then you'll get glitches and it'll just give you more of a headache later, so it just pays to be careful now. Alright, now let's change this to current x rotation and current y rotation. Alright, now let's see if that smooths out a little. Ooh, much nicer. It's a little bit slow. There's still screen tearing going on right now. That might be from me just the recording software, which is QuickTime, going right now is probably causing the screen tearing. But it just feels really smooth, and I feel more like this simulates a human head or human eyes moving around the place more than I feel less like it's a you know, like I feel less like I am using a mouse, and I feel more like this is realistic. But as you can see, I can just keep on doing front flips and back flips, and I'm going to see how many I can do. Here, check it out. I'm going to use my Rat7 and turn the sensitivity up all the way. Woo! That's kind of fun, actually. I wonder if there's a way we could incorporate doing front flips and back flips into a game. Well, either way, let's fix that, because I consider that a glitch right now. And this is going to be one of our simplest lines of code to fix, and I want to put that line of code right here. So we're going to do x rotation equals mathf dot clamp, and we want the variable x rotation to be the variable that gets clamped, and the minimum is -90 and the maximum is 90. So there we have it. Let's test to make sure that works. So that's the thing about designing code, is that there's just so much testing. There we go. So now I can no longer do front flips and back flips. I'm looking all the way down, I'm looking all the way up. Perfect. So all of our code seems to be working so far. I mean, of course we can always go into the inspector and we can adjust. Well, right now the only ones that we would want to adjust is this one and this one, which brings me to a point that I might as well cover right now. All these variables, there's no point in me editing them, especially like these, and I mean these two. I mean, maybe there'd be a reason for me to adjust this, but not really. So let's just get those out of the way so they give us less headache. I could set these variables to private and just write it like that. Oh, whoops, spelled that wrong. Private, and I could just write it like that. But sometimes I want to access these variables from other scripts, and when I write private like that, it makes it, I can no longer access that variable from another script. So what I like to do is to just write at hide in inspector. Alright, and this line of code, basically the only thing it does is it hides it in the inspector. So I just like to put that before all of the variables that I know that I don't need to be looking at in the inspector. So let's see if I cover them all. I think so. Now I should only have look sensitivity and look smooth damp. Yep, so now I can only see these two since these are the only ones I care about. And now I can adjust those. Like, let's say I want the smooth damp to be a little bit faster, and I want a little bit more sensitivity. Let's test that out. Okay, I think I did the smooth damp too much. But anyways, you know, you can just keep on tweaking it until it feels right. But yeah, it looks like we went over everything that we talked about. I'm going to save that. And there you have it. Now you have a basic mouse look script. Now you can, you know, look around in the world and do all that fun stuff. And next we got to do the WASD and make it so that you can actually walk around and all that fun stuff. So I guess until I see you guys next time, this has been ET Ski Tutorials. Please stay tuned.